Hello everyone, I am Smita Kakkar and this is my channel AccelerateAICareers. Today I've brought a very interesting question. So this is LeetCode 380 Insert Delete GetRandom O1. So basically this question is really special because the examiner will expect you to solve it in on an average of O1 time complexity. Now what does this question say and why is it important? So one reason that O1 time complexity, second reason it has been asked by FAANG companies and other companies in lot of their interviews in last 0 to 3 months. And hence it is really special question. Let me show you the companies in which it has been asked. So Amazon, Google, Uber, Bloomberg, even Microsoft, Nvidia. So these are few companies linked in which have asked this question in their last 0 to 3 months of interviews. So I would suggest listen to the question very clearly. It's a little complex one. It's on the higher complexity side. So if you're not able to solve it before me or with me in one go, then pause this video, try to solve it yourself, and then let me know if you have any doubts in the comments here, and I'll be able to take it up and discuss it in more details in my next video. So let's see what does this question say. So you have been given a task to implement a randomized set class which should have three methods. It should have a Boolean insert function, which will insert a value, and it will insert the value only if that value is not present. So it will return true if the item was not present earlier. Otherwise, if it was already present, it will return false. And it will not insert it since it's already present. Now the other method is remove. It will check if the value val is present. If it is already present, then it will remove it and return true that the task has been done and the value has been removed. In case the value is not present, it will return false. Now the third and more complex task is GetRandom. So basically, as the name indicates, it means that out of all the elements, every element has equal probability or same probability of being returned, and it will pick up any one random value or random index and return you that value. So GetRandom function does that. But the main complexity here is not implementing these methods. Complexity is implementing them in O1 time complexity. So let's see how do we go about it. So as it has already been said that we have to implement a randomized set class. So the basic structure has been given here. Now let's assume that you have a hash set here. And in the hash set, you will be inserting or removing or getting random values, because in set, inserting as well as removing or checking if the value is present all takes only O1 time complexity. So that's not an issue there. The problem will come in GetRandom, because when you try to get random values, if you use any built-in function from Python or if you use any random choice function, etc. functions, then also it will take O of n time complexity to find a particular value and return it from a hash set. So you cannot directly do it from hash set. You would have to maintain a list or an array, because a hash set is unordered. It doesn't have any orders or indices, whereas a list or array has indices. So for those indices, you can apply a built-in Python random function. And when you apply that one of the random index is picked up and the value corresponding to that index is returned. So basically you need value versus index relationship to return a value for a random index chosen. So to do that, you have to maintain a hash set along with a list or array. But the problem here is converting a hash set to a list or array is O of n time complexity itself. So you cannot do this way that I will just maintain a hash set and when I have to do GetRandom, I will convert the hash set to list, because that's an O(n) time complexity task and you cannot do O(n). You have to do O1 time complexity task. So we'll use additional space, and instead of maintaining just a hash set, let's maintain a hash set and a list or array. So we'll be maintaining both. So when you insert a value, say I insert a value, say 0. So when you insert a value, you will add it to the hash set. If it is not already there, it will get added and true will be returned. And at the same time, you will also add the value to the list, and the pointer will move to the next index. When you remove a value, in that case, you will pop that value from the hash set and you will also pop that value from the list. But popping that value is a task, because if you have to pop, say, something from the end of the list, then it is O1 time complexity. But if you have to pop a particular value in between the list, in that case, if you pop that value out, you have to move all the values ahead in the list to cover that gap, which is not a one-time complexity. So let's see how will we handle it. Let's take an example and understand the question better. So say suppose I first insert one value here, a digit 1. So when I have to insert 1 first, my hash set is empty. There is nothing inside it. So in insert function, it will check if value 1 is already present, it's not present. So it will insert it here. And it will also insert it in the list. After that, now you insert 2. Now when you have to insert 2, it will check if the 2 value is already present there. It's not present, so it will insert it here. I'll also add it in the list at the same time. Now say suppose you get random out of here. If you have to get random here, then you will just input the indices 0 and 1 in your random Python built-in function. It will pick up one indices out of 0 and 1, and then that value will come, and then you have to give the corresponding value corresponding to that index, which you can get from this list. And that's how the getRandom function will work. But the problem which will come is in remove function. Say suppose you also insert the third value 3, and then the third value also gets inserted in the list. Now you have to remove this value 2. Say suppose if you have to remove this value 2, removing from set it's okay. You can remove from the set. But how will you remove it from the list? Remove 2 from the list, you will first have to find it. And to find it, if it is not present in the start of the list or end of the list, to find it itself is O and time complexity, because you will have to go through each item in the list. Right now it's only 3 items, but there could be more than n items there. You have to go through every item to see if it is 2, and when you encounter 2, then you have to remove it from the list. So that's an O and time complexity task. So that will not work. In your hash set, as soon as you have been given a value to remove, say you have been given 2, you should know which index that 2 value corresponds to in the list so that you can pop it out from the list. So to do that, instead of hash set, I'm going to use hash map. Now, if I'm using a hash map, in that case, I'm saving 1 value corresponding to 0th index, 2 value corresponding to first index, 3 value corresponding to 2nd index, and so on. So when I'm given a value 2 to remove, in that case, I know that in my list, it would be the first index. So in the list, I just have to go and pop the first index. But there's a slight complexity there as well. Say if I go just to the first index and remove this element, then there becomes a gap here. What will you do here? Will you copy any random value? Say a default value, I decide my default value is 0. So every time I remove a value, I will insert 0. But that cannot be done, because if I do that, when I'm randomizing the indices for getRandom, there is a chance that the index 1 gets picked again, and then the value which will come is 0, which is not there in hash map. So you cannot do that. You cannot have a default which is not there in hash map. But then you would say, then don't have a default which is not there in hash map. Maybe have a default, say a number prior to it or a number next to it as a default here. Say I do not have a 0 here in place of 2, but I have a 1 here. In that scenario, if you have a 1 because 1 was before it, in that scenario, when you have random indices being picked, there's a high probability that 1 gets picked because 1 is at 2 places. So that doesn't create an event of same probability. So you cannot have a default from hash map itself. So then do what? So you will have, that at the end of the list, whatever is there, to pop it out is O one-time complexity. So why not we do that instead of doing anything else? Whatever is at the end of the list, replace that here and then pop that value out. That ways it happens in O one-time complexity, because you are not moving the entire list behind the value to be replaced. You are swapping just one element, which is O one-time complexity task. And then you are popping out the last element in the list, which is again O one-time complexity. Now, how do you correct it in hash map as well? So you already popped 2 out from hash map because that was the value to be removed. Now you have to just change the index corresponding to 3. So the index corresponding to 2, you already knew what was the index corresponding to 2. So you have to change the mapping for 3, the value which was at the end of the list, the last index value. You have to change the index value corresponding to it, its key value pair, change it to the value or index which was for 2. That's the entire change you have to make. In this way, your remove function will also happen in O1 time complexity. Insertion is easy. Insertion will happen in O1. There is no change in key value pairs or index and value mapping. So it happens easily. Get random will also work easily. You will use Python built-in function and you will get a random index value and corresponding value you can get from the list because the list has indices as well as values, right? So you can do that. Now, this is the entire concept behind the question here and how to solve it in O1 time complexity. Instead of hash set, we'll be using hash map and we have to update the indices so that the last value in the list gets popped in case of remove function and you move that value to the value which was actually supposed to be moved out, actually to be removed, like we did with 2 here. Okay, so now let's code this function. So first of all, I will initialize my hash map as well as my list. So self dot num map is equal to empty and self dot num list is equal to list. So that's your initialization function. Now let's go to insertion. Now, as I said, for insertion, you need to check whether the value is already present or not. So if it is not present, then only you insert it. So val not in self dot num map. So I will save this in my result. So if it is not present, then you insert it, right? So if result is true, that is the value is not present. In that case, I insert. So I insert this value, and what would be the value here? It would be the length of num list because I am inserting the value, the new value to be inserted at the end of the list. So it would be length of the list. So that's the index you need to save. And then I will also add it to my list because I have to add with the value to both the map as well as the list. So self.numList.append val. And finally, I have to return the result as well. I have to return true since I inserted the value. This is your entire insert function. Now let's write the remove function, which is the most difficult part here according to me. And if you encounter any problem, you will encounter it in remove itself. The rest of the two functions are easy functions. So if you practice this coding, especially for remove function twice, I think you will understand what are the integrities for this. Okay. So first we check whether the value is present in the hash map or not. So value in self dot num map. So if it is present, then only you can remove it. So if the result is true, then remove it. So to remove it, what you need to do, you first need to save the index corresponding to the value to be removed. So the value to be removed is val. So you will save that index in index. Now you will get the last value in your list because you need to replace the value to be removed with the last value in the list. So last value will be self dot num list, and the last value in Python you get it like -1. So the last index is, that's how you can get it instead of last. Okay. So now I will update my indices. So I'll first update my value at the index to be replaced. So this is the index on which this value val exists, and I have to replace this index value with the last value. So self.numList index, and this value I will replace with last val. Earlier it was val, and I'm replacing this value in numList with last val. So what I did, I moved that 3 to the place where 2 was there in the numList. That's what I have done here. Now I will pop the last value because I've already moved it to the index value, so I don't need it anymore. So self.num.pop. This is O1 time complexity operation, so I do that. Now self.nummap, and I will update the indices for value 3 here in hash map. So I will update it to the index value which was there for 2 here because I have placed last value here at index. So self.nummap last val, and I will update it to index. And finally, I have to delete the value val from the hash map also. So to do that, which is O1 time complexity operation again, self.nummap, and I'm deleting it for val. because I have saved the index for last val here, so I don't need val anymore. And finally, I also have to return the result that the removal was done correctly. So I return that's my entire remove function. So what all I did, I first got the value for result, whether the value is present in the num map or not. If it is present, then only I can remove it. So my result value, if it is true, then I proceed towards the removal. And I get the index value corresponding to the val value to be removed from the map. And that's what I did here. And then at that index, I moved the last value in my list to be popped, right? So I got the last val from my list, the very end index value. And then I inserted that last val value in index here, where actually the value to be removed val was present. So now that has been done, I can pop the last value from the list. So I did that. And finally, I update the index in my num map for the last val to index where I have placed it in the list now. And then I delete the val because I don't need that val here. It needs to be removed. So I deleted that. And then finally return result to see if the value was actually removed or not. Now the easiest function getRandom comes. In this, I just use the built-in Python function random.choice. You can use any other functions if you're coding in some other language, but for Python, this is a good function. And then self.numList. So it will pick up one random function there. So this is your entire code. Everything has been done in average O1 time complexity. Of course, the space complexity a bit high, but let's run it and see if it works. Let's see what mistake we made. So the error here was that I returned true instead of returning the result. Now it will work. Let's run. So it's accepted. Let's sum. As you can see, the time taken is very less here and the solution works quite well. I can just skim through the solution for you once again. We initialized our hash map and a list to trace indices versus values pair and do the task in O1 time complexity at the same time. For inserting, we first check if the value is present or not present. If it is not present, we return the result as true. And we also check if the result is true. In that case, we insert the value both in the list as well as in the hash map. So that's what we have done here. And that's since we insert the value at the very end of the list, so that's what is put as the index here in hash map. Now, in removal, we first check if the value is present in the hash map or not. If it is present, the return result will be true. If it is not present, there would not be any removal and the return result would be false. Okay, that's what the question demands. And if it is present, in that case, if result is true, we get the index for which the value to be replaced is there, right? Val. For that, we get the index from the hash map. And then we also get the last value from the list, which needs to be popped up. And then that last value we insert in the list at that very index where val was present to replace it with that. And then we pop the last element in the list because we don't need it anymore. We have already placed it at some other place. Now in hash map, we change the indices. We pop the value out because we have to remove it. And for the last val, we update the index to the new index where it has been placed. For getRandom function, we use random.choice Python inbuilt function. You don't need to remember it. There are so many built-in functions, right? The examiner will not expect that you remember this function. And you get a random choice function from numList. That's what has been done here. And your time complexity would be O of 1. So that's it. That's the entire code. If you have any doubts, ask them in the comments here. If you like my way of solving problems, subscribe to my channel to get your notifications for your daily LeetCode challenge. If there is any specific question you want me to solve further, mention it in the comments. Thank you.